Alright, so let's get started. So the first problem, we're gonna just review real quick. We are gonna write the equation, the full equation for calcium's MCI and for hydroxide. Okay, so we're gonna write the entire balanced equation where we combine the two ions and get the ionic compound. So let's start with calcium's most common ion. If we take a look at the periodic table, okay, calcium is right over here. And if you guys remember from our pattern that we know, it's in the +2 column. So calcium is going to be Ca2+. So that's our first ion. That's our cation. It'll be Ca2+. All right, our anion. So our anion is going to be hydroxide. So we're going to look at our chart and look for hydroxide. And hydroxide is OH-1. So we're going to write OH-1. Okay, that is our anion. So we're going to be writing the balanced equation, so we're going to put a plus in between and draw an arrow. And then we just need to make sure that we balance out the cation and anion. So it's +2 and -1. So we got to balance that out. So we're going to need 2 OHs to balance out the 1 Ca. Alright, so for the ionic compound, we're going to write Ca and OH next to each other. And since we need 2 of the hydroxide, we're going to put the parentheses around it and put a 2 behind it. And that's it. So same thing that we've been doing. For today's assignment, you will have to write the entire equation. So just make sure that you're comfortable writing the plus sign, the arrow, the numbers in front, so on and so forth. No. So are you talking about if it's like if it's like F or something like that? Then no. Then it would just be like CaF2. Yeah, the parentheses only if you need multiple of anything from this chart right here. Yeah, great question. So yeah, don't use parentheses if it comes from the periodic table only. All right, so that is the equation. So let me label it. So this is going to be our equation. You're gonna have to write this for your assignment. Next thing you have to do is write the name. That's what we've been working on the past couple class sessions. So first thing we can do is we're gonna write the cation. Ca is calcium based on the periodic table. And the anion, OH, comes from this chart right here. So we don't change the ending of it. It's going to be hydroxide. Okay, so that's going to be the name of our ionic compound. So this is pretty much what we've been doing for the past couple class sessions, right? We write the equation, and then we write the name. Okay, any questions on the review part? Alright, so today what we're going to be doing is we're going to be learning about something called precipitation. Okay, so I want you guys to write that down. Precipitation. Kind of fitting because it's raining today. Precipitation in chemistry is basically where you take things that are dissolved in water. So things that are dissolved in water. And when two chemicals that are dissolved in water, they react together, they make a solid. Okay, so you basically have like 2 liquids, you mix them together, and all of a sudden when they mix, a solid is going to form. We call that precipitation. So another way to say dissolved in water in chemistry is to call it aqueous. Okay, so write this word down, aqueous. Just means it's dissolved in water. A-Q-U-E-O-U-S, aqueous. And what we're going to do is we're going to be labeling each chemical in our equation with what state of matter they're in. So let's get started with the left side. So there are 3 chemicals, so we need to add 3 notations of what state of matter they're in. So if you ever see an ion, so if anything is plus or minus, it's always aqueous. So what we do is after the chemical, we write in parentheses AQ down here. Okay, so for this unit, for this lab and this upcoming test, the left side of the equation, they're both going to be AQ because we're only going to be working with ions. But later, you'll see other states of matter here. But just to make it easy for you, everything will be AQ on the left side of the equation for this unit. Alright, so these 2 things are dissolved in water. So if we're going to basically draw a diagram, you guys don't need to draw it. Basically what it's saying is that you got Ca2+ and you got OH- that is dissolved in water, and they're going to combine. And we basically want to figure out, is the chemical they make, calcium hydroxide, is this going to be a precipitate? Is it going to turn into a solid when these two things mix? So in order to do that, we need to look at something called a solubility table. So if you guys have these notes up on your screen like I asked you to pull up, we're going to scroll down a bit, and I'm going to show you guys what we're learning today. So this is called a solubility table, and it's pretty simple. We basically just look at the cation that we have and just kind of line it up with the anion, and based on what's on the table, it's going to tell us if it stays dissolved in water or if it's going to precipitate or make a solid. So we're looking at Ca2 plus and OH minus. And if you guys line it up, you see how it says slightly SLSOL, okay? This means slightly soluble, and that means that this is going to precipitate. So on your notes, if you guys want to make a quick reference for what this table says, SOL means soluble. Okay, basically that means whatever chemical you make, it stays dissolved in water. It stays aqueous. Okay, if you see SLSOL, this is slightly soluble, and INSOL means insoluble. And basically this means that they precipitate. It's gonna form a solid. Yes. Okay, so that's pretty much how you read this table. You basically take the cation, the anion, you just cross-reference them, and based on what it says, you're going to write down if it's aqueous or solid. Okay, these blank spots mean the chemical does not exist, and so this chemical won't form. We'll talk more about that later before we do our lab, but that's pretty much how you read this table. Yes. All right, so if you see on the table that it is slightly soluble or insoluble, then all you have to do is add a parentheses S after your chemical to indicate that it's gonna form a solid. And when we do our lab next week, we're gonna be mixing these ions, and you guys will see, and you'll be able to predict whether or not a solid forms when you mix these ions together. Okay. Now, if it says SOL on your table, then you just write parentheses AQ, just like the other ones. Okay. But we'll do a couple practice just so you see a couple examples. But that's pretty much all we're adding on. You just need to cross-reference the ions on the solubility table, and that should just add it onto the equation. All right, so for number 2, we're going to be combining Pb2+, and we're going to be combining it with fluorine's MCI. I'll just tell you what fluorine's MCI is so you don't have to look. It's going to be F-. And we're going to be combining these two together. Alright, so for our balancing, pretty simple. You need 2 fluorines to balance out the Pb2+, so we'll put a 2 right here. And so if we combine them together, we will get PbF2. So this part up till now is pretty much just review. It's what we've been doing. Okay, now today we learned that we have to add the state of matter notation. So basically whether it's aqueous or whether it's a solid. So we said that everything on the left side is going to be aqueous. So on the left side, we're just going to write AQ next to Pb and AQ next to fluorine.
Left side of the arrow.
No, left side of the arrow.
Oh.
Yeah. All right, so let me give you guys a minute. If you guys have your solubility table, look at that, and I want you guys to write the state of matter for PbF2. Is it going to be aqueous or is it going to be a solid? Just write it down next to it real quick, and then we'll go over it, and then we'll move on to the naming. All right, guys, so if we look at Pb2+ and F-, we cross-reference them. It's going to be insoluble, so this does not dissolve in water, which means that the state of matter notation for this is going to be a solid. So this is going to form a solid, and that kind of answers part C. There's this, yes, there will be a precipitate. Okay, so that's pretty much part A and part B. Okay, you just write the equation, you figure out, is it going to make a solid or not? Is it soluble or insoluble? And then you just write if a precipitate will form. Okay. All right, let me give you guys a minute, see if you guys can do the last part of the question. Write the name of this ionic compound. And then after that, I'll have you guys try 3 and 4, and then we'll be all done. Okay, but see if you can do finish up the number 2 with the name. Okay, so for the name, we got PBF2. So we got to look at the periodic table for PB and F. If you take a look at PB, PB is right over here. It is lead. Okay, so we're going to write that PB is lead. Okay, now, PB does not follow the MCI rule, so we have to add the parentheses with the charge. It's PB2+, so we're going to write lead 2.
How do you know when to add the 2 there?
Yeah, if it's not an if it doesn't have the MCI pattern. So if it's going to be any of the ones in the middle, or remember that line that we drew here?
Yeah.
Anything underneath that line, those you need to add the parentheses. Yeah, great question. So if you have a cation with no MCI, that's when you write the parentheses. All right, and then the second part of the name with F. Okay, F is fluorine, and since it's on the periodic table, you change the ending to fluoride. So that's going to be the name of this compound right here. Okay, so lead 2 fluoride. Alrighty guys, so I got the answers up there for you real quick. Number 3 is Ag2SO4, and if you cross-reference it on the table, you'll see slightly soluble. So that's going to make a solid, and the chemical is silver 1 sulfate. It's 1 because the charge on Ag is +1, so that's why it's 1. Yeah. And then for number 4, it's magnesium phosphate, Mg3PO42, and this is insoluble on the table, so we write S, and so we know it's a solid.